Hello dear friends, welcome to my channels. Today's video is very today's discussions is very short. I will discuss only just theorem and some result. No proof, but this theory and results are very important for a learner. Those who want to learn product space of topology. Those who want to learn these theorems are very important for them. So friends, let's start our discussions. Let xi comma ti I equals to 1 to 1 comma dot n be a finite collection of a n topological spaces. Then the collection B equals to g1 cross g2 cross up to cross gn, and such that gi belongs to tau I, and for 1 less than equals to I less than equals to n is a base for some topology on x equals to x1 cross x2 con xn. Then topology tau generated by the base B is called product S, and x comma t is called product topology logical space of the given space. The mapping pi I such that x tends to xi such that pi I x is equal to xi is called projection on the ith coordinate space, and where x equals to x1 xn. Let a index alpha, where alpha belongs to del, be arbitrary family of indexed sets. Also let a equals to cross a index alpha such that alpha belongs to del. Then mapping pi a such that a tends to a alpha, that pi a alpha a is equal to a alpha is called projection map of a into the alpha coordinate space. The mapping pi a is also called evaluation map. Note a, if a alpha is equal to phi for some alpha, then product of a is equal to alpha. If a alpha is equal to a for all for all index alpha, then product of a index alpha belongs to a to del index del. Let x alpha is equal to tau x alpha comma tau alpha, where alpha belongs to index del be arbitrary collection of topological spaces, and let x equals to product of x alpha such that alpha belongs to del. Then topology tau on x, which has subbase the collection B equals to pi a inverse Ga, and Ga belongs to tau alpha a for all alpha belongs to del, is called product topology of Tychonoff topology for x. The space x comma tau is called Tychonoff space of the given spaces. Since Ga belongs to tau alpha a and pi a inverse Ga belongs to B subset of tau, that implies pi a inverse Ga belongs to tau. This proves that pi alpha is a continuous map. Thus, the projection maps pi alpha are continuous. The mappings pi x such that x cross y tends to x, and pi x comma y equals to x for all x comma y belongs to x cross y. Pi subbase base y small y such that capital X cross capital Y tends to capital X, such that pi subbase y x comma y small x comma y is equal to y for all x comma y belongs to capital X cross y are called projection maps of x cross y onto x and y spaces respectively. Important results of product space. If x1 comma tau 1 and x2 comma tau 2 be two topological spaces, and let b1 and b2 be bases for tau 1 and tau 2, respectively. Important results on product spaces. If x1, tau 1 and x2, tau 2 be two topological space and let b1 and b1, b2 be bases for tau 1 and tau 2 respectively, let x is equal to x1 cross x2, then b is equal to b1 cross b2 such that b1 belongs to b1 and b2 belongs to b2 is a base for the product topology tau on x. Let x1, tau 1 and y, v be topological space and let L and M be subbases for tau 1 and v respectively. Then the condition A of all subsets of the form L cross Y and X cross M is subbase for the product topology tau on S x cross Y, where L belongs to L, M belongs to M. And if x1, tau 1, x, tau 2 are the two topological spaces, then the collection of B equals to G1 cross G2 and G2 belongs to tau 2 is a base sum topology on x1 cross x2. If x, tau is a product space of topological space x1 and tau 1 and x2 is tau 2, then T2, then the projections of the pi 1 and pi 2 continuous, and x, tau is the product space of topological space x1 tau 1 and x2 tau 2. Let pi 1 such that x tends to x1, pi 2 such that x tends to x2 be the projection maps on the first and second coordinate spaces respectively. Let f such that y tends to x and be another map where y is another topological space, show that the f is continuous, and if and only if pi 1 of and pi 2 of are continuous maps. The product topology is also the co-Arthur weak topology for which projection are continuous. The product space x1 cross x2 is connected if both x1 and x2 are connected. Let z, tau be the product topological space of topological space x, tau 1 and y, tau 2. Then z is compact if and only if x and y are both compact. Tychonoff theorem. Tychonoff theorem, let x subbase lambda and t subbase lambda belongs to index del be a collections of topological space, and let x, x cross x lambda and lambda belongs to del, then x is compact relative. This word is very important. Compact relative to product topology if and only if each space x subspace lambda is compact. A subset of R to the power n is closed and bounded if it is compact. The product of two second countable spaces is second countable space. The product of any non-empty class of Hausdorff space is Hausdorff. The product space of two Hausdorff space is Hausdorff space. The product topology tau is the coarrest topology for X for which the projections are continuous. The product topology X equals to cross X alpha such that alpha belongs to del is T1 space if and only if each coordinate space is T1 space. Let S be a sequence in a product space X is equal to cross X alpha such that alpha belongs to del, then F is continuous if and only if the composition map pi lambda composed F such that y x lambda continuous. Let F be a map of X into product space x1 ipi, then show that F is continuous, and that implies pi I F is continuous for each projections pi I. Thanks for watching, friends. I tell total 16 results and theorem of product topological space. I hope that it is very helpful for for all learners.